All right, so this week we're gonna continue with finding the point of intersection. Okay, so solving linear equations, but I'm gonna show you different techniques. Now I know that I showed you one technique, right, the comparison method, and it's been a while. So for the starter question, I will ask you to do this question using the comparison method. But the focus of this class is I'm going to show you a new technique known as substitution method, and then I'm only going to be posting two videos this week. So next class it will be another technique known as the elimination method. Okay, and everything will essentially show you how to find the point of intersection. Okay, sometimes it just makes sense to use a different technique because it will be faster. Okay, so when you have a system of equation, right, when you have two linear functions, it turns out that they will have an intersection. Okay, so remember last week we kind of deviated because I started talking about parallel lines and perpendicular lines, but that's important to know. Okay, it's important to know if you will have a solution, if in fact you will have a solution or not, right? In this case, you will, okay, because as you can see, the function on top, right, in green, the slope of this function m is equals to 2, and the slope of the function underneath is 1, okay? Because they have different slopes, they will intersect, okay? And graphically, if you want, let's just quickly sketch the two functions. Again, no need to be super precise. I'm not going to ask you to draw a table to help you. So the function on top, um, the y-intercept of this function is -3. So kind of like just put a dot at -3 over here, okay? And then slope is positive, right? It's 2, so it's increasing. So this one will increase. So it will look something like that, okay? The other function in red starts at 7, so it's going to be way up over here. And so this is your y-intercept, right? 7. And the slope is positive, but the slope is 1. So this one will also increase, but not as rapidly as this one, okay? Because 1 is, not as a higher, 2 is a higher number, basically, okay? So this one will increase, but slightly slowly. So maybe something like this, okay? And this will be your point of intersection, okay? So this is what we're looking for. This, if you want this point over here in blue, okay? So if you think about the coordinates of this point, right, both the x value and the y value are going to be positive, okay? So based on the picture that I have, right? So how do you find the point of intersection, right? So that's a that's that's a question that you should be asking yourself. Now, the comparison method that I showed you, right, gives you a technique to solve this equation. Okay, so what you can do is you can compare the y variable for the function in green to the y variable of the function in red, right? Because both of them have the same variable. I'm talking about this y over here, right, and this y in red, right? They have to be the same because remember the point of intersection means both your functions, right? The one in green and the one in red will at this at this point of intersection, right? Both of them will have the same x value and they will have the same y value. We need to figure out what those values are, right? So we can equate the two y values because they have to be the same. So I'm comparing the two y values, right? So I'm going to replace this y value by 2x minus 3, right? Because y is equal to 2x minus 3, so I can do that. And then I'm going to replace this y value in red by x plus 7, okay? And then all I have to do is just solve, okay? So, right, move your variables on one side and the numbers on the other side. So I like to keep my variables on the left, so I'm going to move this x by doing the opposite. So this is um, x, so I'm going to do minus x, so this will disappear, right? And then that leaves me with x, 2x minus x is just x, so x minus 3 is equals to 7. And then let's get rid of this minus 3 by doing plus 3 and plus 3 on both sides. Okay, so this disappears, and then you have x is equals to 10. Okay, so just be very careful when you're subtracting, right? You always have to do the opposite. Some of you on your quiz, got tricked by the multiple choice options that I gave you because I was assuming some of you would switch, I guess, confuse yourself with the signs, and some of you did. Okay, so don't fall for my traps. Okay, just be very careful. Now, right, so by comparing the two y values, I was able to figure out what the x value has to be. And like I said, it has to be positive. Okay, so based on the picture that I have, so x is equals to 10 is kind of making sense. So this is how you find the x value. Now, how do you find the y value? Okay, so to find the y value, all you have to do is to plug in this x value. Let me just so this x value, either plug it in this function or that one, both of them, right? Just replace your x value by 10 in either one of these functions. Both of them will give you the same y value. They should, okay? If they don't, that means you made a mistake. So let's just quickly do that, okay? So I'm gonna replace x by 10 in here. So it's just gonna be 2 times 10 minus 3. So that's 20 minus 3. That gives me 17, okay? In this case over here, I'm gonna replace x by 10. So 10 plus 7 is also equals to 17, okay? So it doesn't matter where you substitute this x value, right? You can substitute this in either function, and you have to get the same thing. Okay, so again, my advice is, even though you're supposed to get the same thing in both functions, even though you only have to replace it in one of them, make sure you're replacing in both of them, just so that you can convince yourself that you have the right answer. Okay, in my case, I know I'm getting 17 in both cases, so that means I have the right answer. So the coordinate of this point is, right, my x coordinate is 10 and my y coordinate is 17. So this coordinate over here, right, is 17, um, 10 comma 17, sorry, 10, right, x is 10, y is 17. So which is what I expected, right? Again, just by sketching, I knew that both my coordinates had to be positive. I didn't know what the values were, but I knew that both of them had to be positive. Okay, so sketching kind of like, gives you an idea of what to expect, right? If this is what the sketch shows you, and then you're getting a negative number, that means you probably made a mistake somewhere. But if you do make a mistake, let's say at this stage, you're gonna get different y values up there. So you can always double check if you are doing this correctly, which is what you should have done on your quiz. Okay, some of you did not do that. That's why you lost your marks. Okay, this is just a refresher, right? So what I used over here, this technique is known as the comparison method. Okay, so this is what we did last week, comparison method. Okay, so now let's focus on the substitution method. Okay, so substitution method is what we're going to focus on today. So how does the substitution method work? Okay, so in this case, the equation that you have, you can solve this equation using the comparison method, okay? So what you could do is, you could compare the y with the y down here, but that means you need to get rid of this 2x, okay? So you're gonna have to do minus 2x, minus 2x, but then if you do that, you're gonna have minus 3y is equals to minus 7 minus 2x, and then you can divide by minus 3, divide by minus 3, and then just solve for y. As you can see, this is very long. And then you can compare the two y values. Okay, that's one way of doing it. Another way would be to compare the 2x and the 2x, okay, using a comparison method. So that would be slightly faster, because if I solve for 2x in this case, all I have to do is just get rid of this minus 3, right? So I can do plus 3 on both sides. And then by doing that, this equation will change into 2x, right? Because this will disappear. So 2x is equals to y plus 3, okay? And this one, I can also solve for 2x. I just need to move the 3y to the other side. So if I do plus 3y plus 3y, this will disappear. And then you'll have 2x is equals to minus 7 plus 3x. And then you can compare these two functions. Okay, so this one in green if you want, and this one in red, right? Because um, both of them have right, both of them are represented in terms of 2x. Okay, so you can compare the two, like just like we did the starter question, right? You could do so again, let me just be consistent on my colors, right? So this is green and this is red. So if you want, you could do this, and if you don't believe me, you can try this out. So 2x is equals to 2x, and then replace the 2x in green by this stuff over here, right? So y plus 3, and then replace this 2x in red by minus 7 plus 3x, okay? and then just do your algebra and solve. But as you can see, this is kind of long. Okay, there's actually a better way of doing this. Okay, so this is just me showing you what you need to do. Sorry about that. I guess I should have pointed this out, that you don't have to copy this down. But what I'm going to do now, I'm going to ask you to copy this down. Okay, so how does the substitution method work? Remember, the point of intersection is a special point where both functions have the same x and y value. Okay, both of them. So what you can do is you can actually use substitution. Okay, so how does that work? So we know that on top over here, right, in green, I know what my y value is equals to. My y value is equals to minus 2x minus 3. So what I'm going to do is I'm going to substitute this y value down here. Okay, so I'm going to replace this y by this value. Why do we do that? Okay, the advantage of doing that is now if you make that substitution, you're only going to have one unknown, which will be x, and it's really easy to solve for one unknown. Okay, in this case, currently you have two unknowns. You have an x and you have a y. In this case, you also have two unknowns, okay, x and a y. But if you make that substitution, right, if you replace the y value over here by this y value, right? If you replace this by that, then you're only going to have one unknown. Okay, so let's do that. So we have 2x minus 3, but instead of y, I'm going to replace this y by 2x minus 3 because I know that y is equal to 2x minus 3. And it has to be the same y because it's the point of intersection, right? So it's the point where both functions have the same y value. So it makes perfect sense to replace this y value by 2x minus 3, and this is equals to minus 7. Okay, and now just basically um, see, now this looks a lot nicer, right? Because you only have one unknown, just the x, so you can easily solve for that. Okay, so now we're just gonna have to get rid of the brackets. Okay, so distribute this over, and then if you do that, you get 2x minus 3 times 2 is minus 6. Don't forget about the x, and then minus 3 times minus 3 is plus 9, and then you have minus 7. Okay, so again, move the numbers to the other side, right? So I'm going to do minus 9, so this will disappear. And then combine your like terms together. Remember, like terms have the same variable, right? And they also have the same exponent. So I can actually combine these two together. And if I do that, I'm going to get uh, 2 minus 6 is minus 4. Okay, and then just, okay, when you're combining like terms, all you have to do is just, you know, combine your coefficients together and leave the variable the way it is, right? So this is just minus 4x, and then this becomes 9, so 16, minus 16, okay? And then finally, just divide by, just divide by minus 4, divide by minus 4. So this will cancel out, and then you'll get x is equals to 4. Okay, so x is equals to 4. Now, how can you find y? Just like before, I'm going to use this x value, okay, and substitute this x value into the first equation. Why the first equation? Because first equation is like in the first equation, I already have the first equation expressed in terms of my y. So if I plug in x over there, I'm going to directly get y. I wouldn't have to solve anything. So it will be faster. So I'm going to plug it in here, okay, because this will tell me what y is. So let's do that. Okay, so y will equals to 2 times 4 minus 3, right? I'm replacing this x over here by 4, okay? So if I do that, so that's 8 minus 3, that's 5. So my point of intersection, right, my solution is x is 4, y is 5. Now, to convince yourself that this is right, this has to be true for both equations, right? So if I plug in x is equals to 4 in this equation, my y value, as you can see, happens to be 5, right? So let's see if it's actually true, then it also has to satisfy the second equation, right? So this is just me checking. So I'm just checking my work, okay? So if I replace x by 4 and y by 5 up here, do I actually get minus 7? Or I should put a question mark. Do I get minus 7? If I do, then that means I've done this correctly. Okay, so I'm going to use this equation. So 2, I'm going to replace, so it's 2x minus 3y is equals to minus 7. And I'm going to verify this using the solution that I have just to see if I'm actually getting minus 7. Okay, so if I replace x by 4 and y by 5, do I actually get, I'm putting a question mark because I'm not too sure if I get -7, but I should. Okay, so 4 times 2 is 8, and then 5, minus 3 times 5 is 15, and as you can see, there should be a minus sign over it. As you can see, this is actually equals to -7. Okay, so that means I've done my work correctly. Okay, so let me just explain this again one more time so that you guys um hopefully understand what just happened, right? So the substitution method, okay, makes sense to use over here instead of the comparison method, because if you use the comparison method, you would have to either solve for y and then compare the two y values, or isolate for 2x, which will take time. Okay, a better thing to do is to, because you already know what y is, you can just substitute this y value down here, which is what I did. Solve for x. Once you find x, then plug this x value into your first equation. Why the first equation? Because the first equation will give you the y value. Okay, so once you find your y value, which is what I did over here, then this is your point of intersection. Okay, so this is kind of like your if you want your answer. Okay, so this is the point of intersection. But just to be sure that you did this correctly, validate the second equation. Okay, plug in x is equals to 4, y is equals to 5 in your second equation, and see if you actually do get -7, which is what I did over here, and I did get -7. Okay, so that means I've done this correctly. So basically, that is the idea. Okay, so let's practice a little bit more. So now, in this case, okay, again, you could use comparison, but you would have to solve for y in both cases, and it's going to take a while, and then you can do y is equals to y, right? A better thing to do would be to use substitution. Now, you see the first equation up here in green is solved in terms of x. Okay, so last time it was slightly different because last time I had an equation up here in green and it was solved in terms of my y. So I did a substitution by substituting my y value in the second equation, right? So this y value here, I replaced it by the y value on top, right? In this case, I'm going to also make a substitution, but I'm going to substitute my x value down here, okay? Why x? Because, this equation is solved in terms of x. I could make a substitution for y, but that would mean that I would have to solve for y first, right? So you would have to do -10 and then -10, and then you're going to get 2y is equals to x minus 10, and then divide by 2, right? So y will, okay, don't write this down. Y will equals to, 0.5x minus 5, and then you can make the substitution up down here, right? You could do that, but that's a lot of work, okay? Um, that's a lot of work. What you should do is just substitute the x value here by the x value that you have on top, okay? So, because again, right, if we're talking about the point of intersection, we can do that because both functions will have the same x value and the same y value. So we can totally do that. Okay, so let's do that. See, so we have, so we have this, so this one in red. So I'm going to substitute the x value, right, this x value down here. Okay, so if I do that, I'm gonna have the 3, but instead of writing x, I'm gonna replace that by 2y plus 10, and then I have plus 5y is equals to -3. Okay, and there's actually nothing wrong with doing this substitution. And also the advantage, why are we doing this, right? Why are we making the substitution? As you may have noticed, right, in this equation now you only have one unknown. It's just the y. Okay, so when you have one unknown, you can solve for that. Okay, so that's the idea. The idea is to make a substitution so that you um, kind of like eliminate one of the variables. Okay, so in this case, I've eliminated the x variable. Everything is expressed in terms of y. Okay, so again, you're gonna have to get rid of your brackets first. So just distribute, and then make sure you have all your variables on one side and the numbers on the other side. Okay, so 3 times 2 is just 6. 10 times 3 is 30, and plus 5y is equals to -3. So I'm gonna combine again. I need my numbers to be on the right side, so let's just remove this 30. Okay, -30 -30, so this disappears, and then combine your like terms together. Okay, so 6y plus 5y. Just add your coefficients together, right? So when you add the coefficients together, 6 plus 5 is 11. The variable stays the same. And then this is minus 33, right? And then just, final step is to just get rid of the 11. So divide by 11, divide by 11. And then y will equals to minus 3. Okay, y is equals to minus 3. But remember, you need the point of intersection. You need both x and y. So what I would do is I would just substitute this y value into my first function. Why the first function? Because my first function is expressed in terms of x. So I can easily figure out what x is. Okay, so by doing that, I can now figure out what x is going to be. So 2, instead of y, I'm going to write minus 3 because now I know what y is, right? Y is actually minus 3. So 2 times minus 3 plus 10. And when you work this out, 2 times minus 3 is minus 6, right? Minus 6 plus 10 is just plus 4, okay? Plus 4. So now your point of intersection, right? Your point of intersection is, so this is kind of like your final answer if you want, okay? So x is 4 and y is minus 3, okay? So this is your point of intersection. This is your final answer, okay? So maybe I'm not going to put a box here. I'm just going to put a box there just to tell you that this is the final answer. But I'm going to ask you to go a step further. I'm going to ask you to validate if this equation is actually true when x is equals to 4 and y is equals to 5. Okay, so you have 3x. This is just me checking, okay? So just to be sure if I have the right answer, so check. So you have 3 times 4, why 4? Because my x value is 4, right? And then plus 5 times y is minus 3. Let's see if this actually gives me minus 3. Okay, I'm putting a question mark because I'm not too sure. So 3 times 4 is 12. And then 5 times negative 3 is minus 15. Is this equals to minus 3? And it seems like yes, right? Because 12 minus 15 is minus 3. So it is equals to minus 3. So that means I haven't made any mistakes, okay? So this is just a extra work that I'm doing. But you see, that's the great thing about math. Okay, whenever you do a question, you don't have to, wait for the teacher to grade your work to convince yourself that you did really well. Usually on a test, right? You can just do the checking on the side and convince yourself that you did not make a mistake. Okay, so please do that. Now this is a bonus. Okay, so this is, so if you guys understood the 2 questions that I've done up here, including the starter question, the 3 questions, you guys are good. You can go ahead and do the homework questions. I want you to do a lot of questions here, 2, 3, 5, and 6, okay, because you need to practice. Question 10 will be bonus. So this will be this is the the worksheet, the blue worksheet. I'm gonna so this is the worksheet, the blue ones that I give you, right? So see PDF. I'm gonna attach a question. The PDF will be called the questions PDF, and you'll find the solutions. Okay, so the solutions will be given to you in the solutions PDF. Okay, so you can check your work. Okay, so if you understood this much, that's good enough for me. But for the students who would like to challenge themselves, I'm gonna just show you the bonus question. So question 9 will basically show you how to do question 10. Okay, so question 9 is very similar to question 10. So now you have a word problem. Okay, if you're interested, you can, I know some students are, because that's what I got from the feedback that, the Google form that I asked you to fill in. Some students were asking to because just to kind of like those difficult questions that I used to give in class, right? So some students were kind of missing those questions. Okay, so if you would like to challenge yourself, so then watch this extra question. So Joe is 10 years older than 3 times his son's age. Okay, the sum of their ages is 58. How old are Joe and his son? Okay, so we kind of have some information about Joe's age, right? So he's 10 years older than 3 times his son's age. but we have no information about Joe's son's age. Okay, so what I would do is, it doesn't really matter, but a wise thing to do would be to say Joe's son's age, right? I'm gonna say that is equals to um, X, okay? Or, this is kind of confusing, so there's a lot of words. So son's age, right? We know that it's Joe's son, right? Son's age is X, and Joe's age is equals to um, 10 years older than 3 times. So I'm going to multiply this by 3. So 3x plus 10, okay? Based on the information that I have been given, he is 10 years older than 3 times his son's age. Okay, so first you need to multiply the son's age by 3 and then add 10 to it. And then basically the question is saying that the sum of their ages is 58. So, and then, okay, so that's one way of doing this. But uh, yeah. So basically, I'm just thinking in terms of function, how would I position this? But basically, if you want, it's just x plus 3x plus 10 is equals to 58. Okay, so you don't really need to use the function business over here. But what some students or some of you might be thinking is this is fine. Okay, so but just to take it a step further, you don't know what Joe's age is. So Joe's age is actually y, but we know that y in terms of x is equals to um, 3x plus 10. Okay, so this is how you would position this in terms of functions if you want, right? So you know that the age of his dad is y is equals to 3x plus 10. And you know that if you add their ages up, so x plus y will give you 58, but now you're going to make this y substitution down here, okay? Which is what I initially had, which is x plus 3x plus 10 is equals to 58. Okay, so this is kind of like a fancier way of doing it, especially like, using the y and then making the substitution or whatnot. But if you directly get to this stage, which is what I did initially, but then I was like, how is this tied to functions, right? So that's why I had to erase this just to show you. But it doesn't really matter how you do it. Okay, so if you're not using y, then that's fine as well. Okay? If you don't have to use the y, but I was just showing you how it's related to what we're doing. Okay, so anyway, so in this case, I'm just gonna combine my like terms together. And get rid of this number. So just do minus 10 on both sides. So this disappears. And then if I combine my like terms together, then this will just become 4x is equals to 48, right? So you would just divide by 4, so x is equals to 12. But what was x, right? X was the son's age. Okay, so the son is 12 years old. How do you find Joe's age? Just plug in the x value in there, and then just work it out. Okay, so if I plug in the x value, then Joe's age, which is y, right? So y will equals to 3 times 12 plus 10. So 12 threes is 36. 36 plus 10 is 46, right? So Joe's age is 46 because remember y is Joe's age. And then if you add the two together, you're going to get 58. So that's like one way to check your work. Okay, so again, it depends on how good your algebra is. You don't have to use the y. I just did because I wanted to show you how it's related to functions. But if you can get to this stage right away without using the y's, kind of like what I did, then you're good. Okay. So anyway, so try doing the first 4 questions. Solutions will be given to you, and if you'd like to challenge yourself, then do question 10. And like I said, if you have any questions about the bonus question or the questions that I'm asking you to do that are like mandatory, right? This one is kind of like if you want optional. Then please join me during my office hours on Thursday. Okay, I'm only gonna be posting 2 videos this week, so that means you're gonna have Wednesday as a free day to catch up on your work if you're running behind, or to and like I just want you to have enough time to practice, okay? Because again, I think unfortunately my video is kind of long, so sorry about that. But don't worry, there's only going to be 2 of them this week. Okay, so thank you so much for watching this video. You guys have a nice day. Okay, take care. Bye.